All right, now we are looking at 3.6 quadratic inequalities. So we've all used inequalities before. Say something like if we have x is less than 5, we draw a little number line, we put a 5 on it, we're going to have an open circle, and we shade left. Right, so that's the old version that we probably all remember from middle school. In Algebra 1, we probably did linear inequalities. That would be something like y is less than x plus 1, where we would graph the line x plus 1, then we draw on the dotted line, and then we would end up shading. And that shading, there's different ways you can decide how you're going to shade. One of the ways is to pick a test point. So say there's this point 0, 0, we test out, is 0 less than 0 plus 1? Well, yeah, it is. So then we shade the bottom there. So that's the easier version, and now we're doing the quadratic inequality, so we're going to have to graph quadratics and then shade. So let's look at number 41 here. Graph y is greater than x squared minus 3x plus 1. So this is a, he's in standard form. So standard form, and we might not remember it very well, but we do negative b over 2a to get the vertex. So if I plug in negative b, that's going to be negative 3 over 2 times 1, which is going to be 3 halves. So our vertex starts off at 3 halves. The other half of our vertex, I'm going to have to plug back in 3 halves. So I'm going to say like f of 3 halves. And I'm going to get a calculator and just type that all in together. So I'm going to have parenthesis 3 halves, parenthesis 3 halves squared. I haven't used a real calculator in a long while. 3 halves squared minus 3 times 3 halves plus 1. And that gave me negative 5 fourths. Negative 5 fourths. If you want to do them by hand, that's just fine. It probably would have been faster had I just done that by hand. But now we're going to graph this vertex here. Positive 1.5, this is 1.5, and then negative 1.25. So somewhere in that region. And then we can do some other points here. Our a is 1, so we could use the numbers 1 and 4. So up 1 over 1, that would put us in right in that region there. And then up 4 and over 2 would put us, well, we were at negative 1 1/4 plus 4 is going to be 2 3/4. 1, 2 3/4 over right in this region, and then over in this region. Right, it's not perfect. But right here, we have a great plain old greater than symbol, so we're going to use a dotted curve. And then we're going to pick a test point to see, does it work out? Yes or no? And we're going to decide how we shade. So let's pick out this point right there. It's the point 1, 1. And if I plug him in, we're going to say 1 is greater than 1 squared minus 3 times 1 plus 1. 1 is greater than 1 minus 3 plus 1. So 1 is greater than negative 1. That's a true statement. So I'm going to shade towards the point 1, 1, which is the inside. That's example, what was this, 41. Now 41, that one was kind of hard because we got these fractional vertex there. 42 is going to be quite a bit easier here. First off, he's not in standard form. He's in, well, I guess vertex form. The vertex is going to be at 0, 0. And then the negative 3, you use the numbers 1 and 4 times negative 3 to give you negative 3 and negative 12. So you go down 3 and then left and right 1. And then for our next ones, we could go down 12 and then left and right 2, but we're not going to do that. We're just going to leave it as is. This is a less than or equal to symbol, meaning that we can do a solid line. And then we have to decide where to shade. We can pick a test point. I'm going to pick out the point, I don't know, 0, negative 1. That's 0, negative 1. If I plug that in, I'm going to get negative 1 is less than or equal to negative 3 times 0 squared. So negative 1 is less than or equal to 0. That's a true statement, so we shade between there. Looking at number 43 here, we're going to start off by trying to set this as x squared minus 3x minus 10 equals 0. Now, big thing that is different about 43 than in 42 is that there's no y, right? There's no y in this. So whenever we graph this, we're going to just use a plain old number line. So first off, like I showed, we're going to set it equal to 0, not just less than, but equal. And we're going to solve this. This will factor to be x minus 5, x plus 2 equals 0. So what I did is I took my negative 10 and I said, well, that's really negative 5 times 2, and that adds up to be negative 3. Now here I can say, well, x minus 5 is 0, and x plus 2 is 0. So x is 5, and x is negative 2. Now I look at my number line. We need to put both of these numbers on here, and we want a number between them and on the edges. So I'm going to put a negative 3 out front, and then we'll say negative 2. Let's put a 0 in the middle, maybe a 5 over here, and a 6. Because this is a less than symbol, we're going to use open circles on the negative 2 and the 5. Now we have to decide how we're going to shade. Are we going to shade the edges? Are we going to shade the middle? Or some combination? And we want to test out these different values here. We're going to test out the negative 3, the 0, and the 6. So we're looking at this, and that. We need to see what are we going to shade. So if I say x equals negative 3, that's going to give me negative 3 squared. I'm plugging into the very original guy. Negative 3 squared minus 3 times negative 3 minus 10 is less than 0. This gives me 9 plus 9 minus 10 is less than 0, and that's not going to be a true statement. This is going to be 18 minus 10 is less than 0, and no, I am not going to shade this region. Now I look at x equals 0, and I want to see about plugging him in. 0 squared minus 3 times 0 minus 10 is less than 0, and we can see pretty quickly that is going to work out, and we get to shade the middle. Lastly, we check the right side there. I'm going to check x equals 6. And I'm going to have 6 squared minus 3 times 6 minus 10 is less than 0. This is 36 minus 18 minus 10 is less than 0. This gives me 36. What would that be? Minus 28 is less than 0. And that's not going to be a true statement, right? 36 minus 28 is a positive number. He's not less than 0. So we do not shade that region there. And this right here is going to be our answer. Sometimes we might want to write that back as an inequality. And if we wrote that, we would say negative 2 is less than x is less than 5. That's a compound inequality back from Algebra 1. All right, there is 43. We want to have him equal to 0. So I'm going to say 2x squared minus 11x. Then I'm going to add my 9 is less than 0. Now we can look at it, we're going to try to solve the left side as if it was an equal sign. 2x squared minus 11x plus 9 equals 0. We're going to pretend that it's equal to 0 just so that we can solve. Trying to find something that factors. I'm going to say 2 times 9 is 18. That breaks apart to be, let's say, negative 9 and negative 2, right? That adds up to a negative 11. So 2x squared minus 2x minus 9x plus 9 equals 0. So 2x times x minus 1 minus 9 times x minus 1 equals 0. Right, I pulled out my 2x in the front and the negative 9 in the second spot, and now we're going to have x minus 1 and then 2x minus 9 equals 0. So x will be, skipping a couple steps there, 1 and 9/2. Now I want to look at my number line like we did last time. We'll put 0 in the middle. 1, 9/2 is 4.5, so we'll put 4.5 over here. We'll put 5 to the right of it. Let's maybe put a 2 in there as well. We're going to have an open circle on 1 and on 4.5. And now we need to test these out. And whenever we test them out, we can either test the very beginning or we can test out the new one that we created. I think it's normally easier to test out the new one that we created. So if I test out x equals 0, that's going to be 0 minus 0 plus 9 is less than 0. That is not true, so I am not shading this left region. Now x equals 2. 2 times 2 squared minus 11 times 2 plus 9 is less than 0. That's going to be what? 8 minus 22 plus 9 is less than 0. And that's going to be a true statement. So I am going to shade the middle. Lastly, I'll try out the 9 halves. X equals 9 halves. And that's going to be, let me get my original equation on my screen, 2 times 9 halves squared minus 11 times 9 halves plus 9 is less than 0. And we want to know, is that true? 2 times 9 halves squared is going to be 81 halves, I guess. Yep, 81 halves minus 99 halves plus 9 is less than 0. And that is going to be, what is that going to give me? Right, that would be 18 halves plus 9 is less than 0. That's 9 plus 9 is less than 0. That is not a true statement. So we are not going to shade the edge there. So we're just shading right there in the middle. Maybe I'll make my number line a little bit nicer here. There we go. And there's our answer there. All right, that is example 44. And that is your graphing inequalities. The ones that are going to be more common on homework or test will be the ones that look like number 41 or 42. All right, that's all.